Well, good afternoon. Welcome to this session on digital engineering and additive manufacturing. The Department of the Air Force is investing billions of dollars in upgrading the way that we build and that we design our platforms and our systems. Let me tell you, if those ads don't get your heart pumping, I don't know what will. I hope you had a great lunch and had an opportunity to meet with mission partners. I am the Chief Technology and Innovation Officer of Space Force, Dr. Lisa Costa, and I just wanted to give you a couple sentences about how Space Force thinks about digital engineering and additive manufacturing. From a digital engineering perspective, we are not just looking at DE from an acquisition perspective. We are looking at digital engineering as a key component of the entire thread, from acquisition to training to TTP development to force design to moving into operations. In other words, train the way we fight and fight the way we train. And so we want guardians and airmen to be able to compare blue on red and actually go up against one another before we even put an RFP out. So that's the way we're thinking about digital engineering. And then how we're thinking about additive manufacturing, think about trying to do logistics and supply chain in space. When something breaks, it's really hard to get things there. So I think there's a lot of opportunity in terms of innovation and new thoughts around different business models from that perspective. So with me today, I'm incredibly excited because we have really three thought leaders in these areas that I'll be introducing. They'll have a few minutes to talk about what their organizations are doing, and then we'll go over some Q&A. So with that, let me introduce Rear Admiral retired Mike Manazir. He's the former Director of Air Warfare for the Navy and now the Vice President of Boeing Global Services. And I said to him, it's very interesting that Navy Admiral is in charge of air. And so Mike now leads business development, sales management, and market positioning in the global government services market. Then we have, we're sitting in different order, so let me introduce David Stagney, the founder and senior director of Pratt & Whitney Gator Works, and I told him I was wearing Florida Gator colors, which is orange and blue today, who leads efforts to develop and execute strategies for rapid prototyping and technology development, delivering new capabilities that result in enhanced mission effectiveness and lower total cost of ownership. You know, to me, when I read that, I thought to myself, skunk works, that's a lot of fun, right? And then last, let me introduce Ryan Tintner, Vice President of Digital Transformation for Northrop Grumman. With more than 18 years at Northrop Grumman, Ryan is responsible for overseeing the company's digital transformation activities across the full digital thread, ranging from digital engineering and manufacturing to the supply chain and project execution. So with that, let me start and ask Admiral Manazir to start us off and talk a little bit about what his organization is doing.
Thanks, Lisa, and it's really nice to be here with my colleagues on stage at the AFA, AWS, and for those of you in the audience, or for those virtually, we all know why we're here. And it's going to the Chiefs accelerate change or lose paradigm. Why is a Navy Admiral talking about this kind of stuff? I was the Director of Air Warfare on the Navy staff from 13 to 16, and then the Director of all capability for the CNO on that staff before I walked out, and that's where I was focused as well, is increasing the capability of our naval air forces coming off of carriers and other deployed sites. I'm a fighter pilot. There is no or lose. There are no points for second place. We should all know right now why we have to accelerate change. And in my years of doing this, from 2013 to right now, consistently, we have not embraced accelerating change in the digital space. We have not partnered adequately across the defense industrial base in the United States government. Lisa's intro was perfect, because if the U.S. Space Force is focused on that kind of innovation, you will find so am I and my industry partners here. So we have to strengthen that space. In order to win the next fight, some of which is in front of us right now to the east, those who move information around the battle space most efficiently and effectively are the ones that are going to win. Those of you that are actually listening to me are going, well, that's not new. It's the same when we were throwing rocks at each other. That's correct. But the speed of the fight these days is so fast, that machine speed. We've got to be able to take the digital thread from design of platforms all the way to sustaining the platform out front in contested logistics. This is the means with which to do contested logistics in a battle space in which we are going to have long lines of supply. If you set up the ability to do contested logistics with advanced manufacturing and additive manufacturing as a piece of that, being able to move information to build a part someplace, you're going to reduce the supply lines. If you use design engineering in the manufacture of airplanes, like Boeing is doing in our advanced manufacturing spaces with advanced composites, special coatings, a digital thread from design. Lisa talked about it. We can go fight before we even fly. You reduce people, you reduce logistics chains, you keep parts on the wing longer. You can make decisions in a space where somebody is trying to make you not able to make those decisions. So it's information. We need to accelerate that change. In Boeing, we are investing capital investments in building the types of facilities that will be able to move these things forward. Small example. For the T-7A, which you see here displayed, and we're wonderfully part of the United States Air Force in this training and sustainment system, we designed that airplane from the get-go digitally with digital models. We then built a couple of pre-production models that have been flying them. We also built the F-18 Super Hornet along with our partner Ryan down here in Northrop Grumman. When you take the aft end of the Super Hornet from Southern California and you bring it to St. Louis and put them together, it takes about a day and a half to drill, shim, make it all fit, because they're stick-built. The T-7A is partnered with Saab and Boeing. Pieces of the airplane come from Saab to the St. Louis site, put it together. It takes 30 minutes. Full-size determinate assembly, FSDA, built on a digital model, allows us to do that in 30 minutes. The digital thread that started with that T-7A also allowed us to fix a wing rock problem in testing. Company testing, Air Force hadn't tested it yet. We saw the wing rock, went back to the model, back and forth with the model, put a fix into the model, wing rock fixed. Air Force hasn't even flown the airplane yet. So to Lisa's point, you can go back in the model and extend that model all the way through. We need to accelerate change. We need to partner to do it together, or we're going to lose. Losing is not an option, so guess what we have to do? We have to accelerate change and partner together. I look forward to your questions.
Great, thank you, Mike, and thank you to the AFA and everyone for hosting us here together. Again, my name is Dave Stagney from Pratt & Whitney's GatorWorks. The mission that we were given in GatorWorks was to find a way to cut our cost and lead time for new development by 50%. So we heard the need to change, and we've been innovating along that lines. But Pratt & Whitney has been flying engines both on our commercial and in our 5th-gen fighter fleet for years, collecting full flight data from every flight. We're only now beginning to see the power and use our imagination to figure out what we can do with that data to shape not only how we fly, the spares, the way that we move engines through the depot, and the way, again, that we design and build them. So that full product lifecycle digital thread is absolutely part of the solution that you talked about. And figuring out not just how to innovate locally and build tools, at each step in that product lifecycle, but again, connect each of those pieces across the product lifecycle so we can optimize those solutions going forward. It's a real challenge. We have incredibly powerful digital tools that we use to design our products, physics-based models, all the things that you mentioned, Mike, but how, again, do we allow our business processes and our engagements to actually figure out new ways of doing things in a much faster environment. I'll give you an example. When we designed a new engine, we just had a development program recently, we had 25,000 requirements that we were given, you know. Are all of those essential and necessary to meeting the mission? Many of them are. How many of them drive the cost and drive us to sub-optimize that design in ways that no one, the most brilliant people on our team can't figure out? It's such a complicated system, and that's just for the engine, let alone the entire aircraft and the family of systems surrounding it. So how do we work together in that early phase to really understand what are the right requirements? How do we narrow down and focus and trade to understand what's really going to provide the benefit? Those same 25,000 requirements drive testing. We had an engine recently with 2,500 sensors on it as we're going into test. It took over a year just to install the instrumentation on that test engine. Again, did we need all of those? And could we have used our model-based systems engineering approach to truly optimize not just the test program for that engine, but the design of the aircraft and the way all those systems integrate together? So we're just on the tip of this, and I'll give a couple examples later on the sustainment side where we're seeing, true value right now today. But again, we're really excited in figuring out the right architecture that we can do this collaboration together in real time, securely, and competitively as a nation is one of the things that we're really excited about working on.
All right, thank you. I'm Ryan Tintner from Northrop Grumman, and as you mentioned earlier, I lead the digital transformation for the company. And I think it's really a nice setting here that digital engineering, we've all been doing digital engineering for a long time. I mean, I look a decade ago, even in advancements on F-35, when we looked at how you do an assembly line and how you bring that kind of innovation in. But really, we're at the point now where you can actually bring together across the life cycle in a way you couldn't do it before. You mentioned process and collaboration, and those two areas are huge for me. When you think about the processes that we do and how we integrate, in the past, we used to take each phase of the life cycle and we created processes because it was too hard for us all, even within one company, to go really work together and say, how does my design impact my manufacturing, impact my sustainment? We have different models and different tools and different standards for it. And really, with the power of information and computing now, we really can process all of that as we come up with models and ways to do it. But the processes are really what's in our way. We have different processes and we have different people with different types of functional experience. I think we're looking at a big transition here, not just in technology, but in the way we work, right? And so the grand irony for me of digital transformation is the more that you think about technology, the more you have to double down on people, communication, and culture, and how this is all really going to work. I always think it's interesting in these panels, we were talking beforehand, that we are equally competitors as we are teammates here. And if it wasn't clear to people earlier, the last couple weeks, I think, make it abundantly clear where we are in a joint future together. And we need to go figure out, with the models of what we have and with the models of what we can have, how do we optimize to get the best result to the warfighter now? And I think we're highly motivated, especially in the last few weeks here. But the challenges ahead of us, too, are in data, right? The things that have held us back in the past have been data integrity, and we have different versions of the same information. And once you get there, it's kind of scary, the information world we live in today. And I'm guessing we'll talk about that a little bit more as we go on here. But what we need to look at is how we communicate our information together to get to these key solutions. I'll give one example of how you mentioned earlier, we need to design and train how we fight and fight how we train. We're trying to pull all this together and put it really in our DNA. We had just put out some examples on our digital test fleet. In the past, we used to do digital design, and then we would go build it and we would go fly it, and very proud of our fleet of aircraft. We realized we have to get to a digital test fleet. So we put out an actual digital version of our test fleet, and we're forcing folks internally to say, your models need to be testable before you fly. The amount of the life cycle that you can reduce just by doing that is tremendous. And then when we crack the nut here on making sure we can openly share all these models, it's amazing what we can all do together. So again, I'm excited to be here today. This is such a critical topic and fundamental to our security.
Thank you so much. Mike, there's probably no one here more steeped in the knowledge that multi-domain operations is really critical for achieving strategic advantage. So I'm wondering, in terms of at least the elements that you operate, what have you been doing in terms of trying to bring those multi-domain operational effects to the work that you're doing?
Thank you. That's how we're going to operate. It is going to be multi-domain. As a matter of fact, we're not going to be able to dominate any domain. Used to be able to say that. We'll be able to achieve local superiority. Boeing works from seabed to space. This Air Power, Space Power Symposium is going to discuss, of course, how do we establish superiority in air and space. You won't dominate. It's pretty obvious. It's too complex. So the ability to move information around is what's going to be key. Now, inside of that multi-domain operations, you have to be able to sustain your aircraft and spacecraft forward. I'll go back to the contested logistics challenge. We classify our platforms, and I'll stay with air for a second for an illustration standpoint. And you know what, in fact, I'll go home for a minute. I have a 1983 step-side Chevy pickup. It's got a 4-barrel carb, 350 horsepower engine, shifts, and of course, to run that engine, there's spark and fuel and air. So if it ain't running, I pick the hood up, I get in there, and I start messing around and see if I can figure it out. I also have a later model Mercedes sedan. It takes spark and fuel and air. My first troubleshooting, though, I can't do it. I have to take it somewhere, and they plug something into it, take the data off. We are applying our legacy systems to every vehicle we have. And so right now, we have systems that take care of fleets of airplanes that come in and we push parts and we push stuff into the multi-domain operations. We're taking care of the late model Mercedes sedans, F-35, F-18 Super Hornet, Growlers, F-22s, like we're taking care of my 1983 Chevy. We've got to stop doing that. At Boeing, we classify our three sort of digital capabilities in three basic columns. So C-17 we call a pre-digital aircraft. An F-18 and F-15, for example, digitally enabled aircraft. And then MQ-25, unmanned refueler going on board the carrier, and the T-7A as digitally native aircraft, maintained differently, but using the digital thread. So most compelling example I can tell you is, of course, with the T-7, we've got data coming off. With the F-18, we've got data coming off, but we're not doing such great work with the data with our Navy partner. And so we're using tools like a fix effectiveness tool to show the maintainer where to go to shorten the repair time instead of open the manual, start at step one. And then in the C-17, which we call a pre-digital aircraft, that aircraft is moving data around a data bus. It has since we built it. We couldn't get the data off. So we created a box called an aircraft data reasoner. It plugs in on top, takes the data off of the airplane, and then can be used with a PCM CIA card in a terminal for the technician who knows what he's doing to be able to look at it and say, this is what's wrong. The UK RAF has been using ADRs on their small fleet of C-17s now for years. The diagnostics coming off of that ADR, in other words, a box on top of the bus, has saved 4 million pounds of fuel in engine runs. Contested logistics, long supply lines, that's 4 million pounds less maintaining a C-17 forward. They had an aircraft on the ground and the aircrew couldn't figure out what was wrong with it on pre-flight. It was doing some funny things. They downloaded the data off the ADR, technician took the thing and a sneaker net, they got a flyback, so it flew back to the UK, plugged the card in, and it turns out there was a switch in the cockpit in the wrong spot. The C-17 has some interesting maneuvering characteristics down low, dropping paradrop stuff, and so this software is able to stabilize the airplane. If you have that switch during pre-flight, it starts doing funny things on the ground, and they didn't know because they don't usually use that switch. Switch is in the wrong place. No, it's not. Aircrew switched the switch from that place. Put the switch back in the correct place for pre-flight, your airplane's fine. They save the cost of putting a team on the ground. Contested logistics. So that's how we classify those things in multi-domain ops, is the ability to gather information, reach back over a 5G link back to the United States, which we have now. We have to get the assurance right, critical information assurance there to make sure that happens, but we've already demonstrated it. And then be able to say, this is what you do to fix that, and the airplane's back up again.
That's great. I love the example of connecting back and reach back capability because, again, in space, at least, we rely on that capability quite a bit. And I came from special operations where, you are deployed globally, and always having that reach back capability is a critical factor. Actually, David, I'm going to ask you a question that I was going to ask Ryan, actually. And because it really struck me when you spoke about your mandate, right, of 50% reduction, right, in cost. And so my question, having run a lot of and I use the term skunk works, but did you start off with existing Pratt & Whitney employees, or did you start off GatorWorks kind of going out and bringing in outside individuals, and then based on that answer, how did you establish the culture and really the focus of that rapid turnaround capability?
Oh boy, this is a long story. I'll try to make it short. Those are all great questions, Dr. Costa. For us, it was the short answer was the very first thing we did is we partnered with a local small business, and we took the team off-site and worked directly with them. And the very first demonstration project that we did in GatorWorks, we only gave the team 3 requirements for the new engine. We gave them a dedicated team, not people who were split, the best experts end up getting split across 10 different projects, and your project is burning $1 million a day because you can't schedule a meeting with specialists that you need to review part of the design. So we had a dedicated team, and we banned all 2D drawings. We went directly from the Unigraphics straight onto the 5-axis machine. We did blue light inspection, so we were able to actually inspect the parts without breaking the setup on the machine and kind of tweak the models. And then we, the team basically, again, they were developing a minimum viable product. So we adapted the agile software model to the hardware side. And that's a very, very difficult thing to do when you think about making that transition. I want to talk a little bit about Agile as well, because I think that's the biggest cultural shift and process shift that's really going to help us change. The minimum viable product is not the final product. It's really, if you do it right, it doesn't make anyone happy, but it proves what is potentially possible, and it unlocks the team's innovation when they're thinking and focused only on meeting the 25,000 requirements, and they're thinking only and focused on meeting the earned value measurement schedule that someone laid out 4 years ago, and being held to every single milestone on that schedule, it takes all of your creative brain power away from actually solving the problem for the warfighter, right? So we use this agile approach, and we said, you have 3 requirements, go and figure out how to make this happen. We went from the PDR to actually fabricating the engine core and the test stand, which was rusting out in the backyard, and we sandblasted it in 5 months. So we were able to kind of drive some huge innovation there. And again, that was a combination of both the digital side and really the agile. If I can just go back and give one quick example on the sustainment side, though, again, because that's where 70% of the Air Force acquisition budget goes, and you're exactly right there. We just launched, Pratt & Whitney just launched on one of our 5th-gen engine programs in partnership with the Air Force. We're just activating right now what we call a usage-based lifing system. So typically an engine is going to have X number of hours before it has to come off wing and go into the depot, and that's all scheduled. And when it comes in, they basically get a standard router that tells them tear the engine down and figure out what to fix. So we created a digital twin, and for the last 2 years, we've been validating, taking all of that full flight data for each individual engine and figuring out the life of that engine on wing and the life of the individual parts, whether or not they need to get individually replaced or not. I mean, if you ask my wife, I drive like my grandfather, right? And she drives like, our daughter's going to drive when she's 16. So I think our car gets a little bit of different wear and tear under those different circumstances. And that usage-based lifing, now we have created and validated this digital twin for every engine in that 5th-gen fleet. And just on that one program alone, it's expected to save $800 million in sustainment cost over the next life of that program. So we can apply that to all of our programs. And again, that's just taking the digital twin on the model we have right now. The next step is then to drive all of that data back into our design and back into our requirements definition. So we're taking AI and basically creating parametric models to help us drive down that sustainment cost and design that right in from the beginning.
No, those are great examples, and you hit on something that's so important in terms of threading digital engineering all the way from acquisition to operations, and that is being able to apply then AI to not only do predictive maintenance, but also to be able to understand the art of the possible and get those models into the hands of these really incredibly gifted airmen and guardians to really, and I focus on the gaming environment, right? We want them to game them and to be able to say, back to acquisition, hey, if you just tweak these 2 factors, you get a 75% increase in capability. And I think that's really where some of the exciting discoveries lay. So along those lines, Ryan, I had a question of you, and that is, it's clear you're very involved in digital engineering and additive manufacturing, and was wondering if you could give us some examples of some of the payoffs that you're starting to see in that environment for Northrop Grumman.
Sure. I think that the payoffs, honestly, as I said, have gone back a long time going forward here. Across the digital engineering chain, if you look at sustainment alone, right, one of the things that we're working on heavily here is that forward-looking modeling to say what requirements really need to be early on, and is the juice worth a squeeze? Right, and so one of the things that we're seeing is you can start to design, say, an aircraft or a weapon or a sensor and have all these requirements, and you can even do it agilely, right? But do we really understand, especially when we're in this multi-domain operations, these things are networked together, can you do this significantly cheaper and understand what the total sustainment impact is? And so across a variety of sensors, right, especially these sensors that are now getting into digital models earlier, right, the full digital acquisition chain, we're able to really look at what's the impact and do I really need these bells and whistles when I know that other things are available as well. That's one of the reasons why we drove heavily to this digital twin within our test environment, because we really need to go out and test whether or not these models that we have actually validate against what's really flown. And I think you see a tremendous amount of cost avoidance throughout the life cycle here. I'll give some generic examples that will relate here, but one of the things that's really hard to quantify for the exact dollar is cost avoidance. But there are so many places where if and when and now we do detect issues and errors that come out of even parts that come in incorrectly from a vendor or drilling that was done incorrectly, we could have detected it, but we didn't have the information together. We get so far down the cycle that we have to completely open up, redo, scrap. That's cost, that's schedule, that's significantly longer to get to the field. And that's all before we even get to sustainment. And so I think it's that detection now, all going back to a common source of data, common authoritative data source that in the past you would be verifying against an incorrect data source. And all of that is significantly paying off both in the aerial domain as well as in the sensor domain here. And I think what you're seeing right now, and again, I go back to just the last few weeks here, and as we're all huddling up closely to say, how does this all really work together? We can do significantly more without putting as many bells and whistles where they need to go if we look at how the total emergent properties of a system play out when you get into sustainment.
Absolutely. I had one of my acquisition folks tell me that I was such a special operator. And I said, well, what do you mean by that? And they said, well, because, ma'am, it's always just good enough for you. Just do it good enough, right? And I think fundamentally, when we talk about failing fast in DoD, we can fail fast in Agile, on 2-week sprints. That's what allows us to fail fast. Let me tell you, nobody wants to fail, quote, fast on a 5-year development, project. So I think there are tools and techniques that allow us to test, understand, try, and we can fail fast and not feel the pain of that failure, but instead learn from it. Yeah, that's a lot of pain.
But you have to think about, sorry to interrupt, but you have to think about, constructing a program differently from an Agile standpoint, right? Mm-hmm. So the first time we rolled out, and we met with our senior executive team, and we presented Agile. The chief of staff called me afterward and said that was the absolute worst meeting I've ever been in Pratt & Whitney ever in my life. we eventually did a couple pilots, and we scaled up. And the very first pilot, the team basically said, well, the first planning increment will be 25% of the design, and the second planning increment will be 50% of the design. And that's not Agile at all, right? The first planning increment has to be a 2D version of the entire engine laid out with plus or minus 10% of your fidelity, right? And so we scaled up a team. We have a design team right now, 300 people working on full-scaled Agile. And the very first planning increment, they did that, and they found a major system integration problem well over a year earlier than they would have done under a traditional PDR schedule.
I'm glad you said that because, we tend to think about delivering 2D products, right? How many of us have received this stack of requirements documents or, here's the, just the proposal documents. We don't want to have to give an engine to 50 different units, right? Instead, why can't we give them, VR glasses and having them learn? And this is an interesting statistic, but 86% of our airmen and our guardians, ages 18 to 34, view themselves as gamers. And they have developed the skills that gamers develop, multitasking, being able to work in multiple dimensions, et cetera. So I think that's really critical. I'm going to ask one last question because I don't want to take the time. But if you were to give Air Force and Space Force advice on how to best, really adopt digital engineering and additive manufacturing within every phase of our systems approach, what would you say?
I'll start. I'm going to riff off of what Dave said. So 25,000 requirements. And so it's kind of funny here. If you take a look at this stage, is there a small business entity up here anywhere? No, I think we're pretty much established companies. And you hear these wonderful things that big companies are doing. Yet we're still bound by the contractual DoD 5,000, 25,000 requirements. What I would ask is we partner. And we look at, with RFIs and RFPs, what those critical requirements have to be. And recognize that companies are willing to innovate, change. We're doing Safe Agile DevSecOps right now in Boeing to go after sustainment, in design of our platforms to go after sustainment. Don't give us 25,000 requirements. We have a contract right now for a recompete that actually says, here's the minimum number of people you have to have. We can propose a digital solution that will just go, that we're not interested in a digital solution. Minimum number of people have. So open it up. By the way, we can use the DoD 5000. There are methods in there to be able to do that. You can. We can. Secretary Kendall will tell us that we can. So if we partner better, open it up, what are you bringing as the best athlete? What actual requirements are going to make a difference? Think about digital engineering and what capabilities there are. We can bring company-funded risk. We will buy forward that the DoD, Space Force, and U.S. Air Force could capitalize on, and we could go forward together in a partnership.
Yeah, so I think that is a great answer. I'll go one step now after that. We have amazing capabilities, and industry beyond just aerospace and defense have amazing capabilities coming out faster than we can even imagine. One of the things that really challenges us is security and the ability to be as agile in the security and cross-domain areas as we need to be. And even when you get into classified, all the different levels, we need to have a much better way to bring information in and share, even once you're at that classified level. I think we need to really closely look at where does security and security definition need to be, and what security level does it have to be at, so that we can get better sharing across programs and capabilities. And I think that goes one step even further. When you look at unclassified, we partner with vendors and small businesses, and they provide us software capabilities and SaaS capabilities. We don't have that capability when you get up into the security levels. It's not as open as it needs to be, and I think that's why we don't see the degree of innovation and agility that we need to at that level.
Definitely agree. Yeah, the reference architecture and the security protocols and how we're going to be able to create these integrated development environments, right, where we can actually work together and be able to put those together in less than a year, right, is absolutely critical.
No, absolutely, and I know there are panels that are going to be talking about this over the next day and a half, which is focused on how do we get to continuous ATO in a DevSec environment and have folks developing in that environment and not necessarily and getting some of those things off of the dip, right? And I think that's really an important area. I want to thank our panelists. Just going to give you, 30 seconds if you have any last thing that you want to say, and then I'll provide some wrap-up remarks.
Oh my gosh, the last comment. I will end where I started. If world events right now don't convince you that we need to accelerate change, then we're going to be at full-scale warfare, losing Americans and losing capital assets if we don't change. It's been right in front of us for a while. We need to change. Change is through this digital engineering, advanced manufacturing, additive manufacturing, using our digital space. We are in the middle of a second industrial revolution. Commercial has already bought into it. We need defense to buy into it so we can bring the full power of American ingenuity and innovation.
Absolutely believe it. And the biggest challenge that I see and where we could apply digital as well is on our lead times, our manufacturing and supply chain lead times. So sustainment is one thing, right? But when you have parts that are 3 years lead time, right? We can't ramp up, we can't meet the need. We've got to think of solutions like an engine in a box. You deliver a shipping container and you can print out 90% of the parts right there, or an aircraft in a box, things like that. We have to think about how other industries have disrupted and changed their supply chain with digital technology, and we need to do the same thing in aerospace.
Yeah, and I'll just wrap all that up together. It's a comment someone made to me the other day. Nothing great happens alone, right? And the key here with digital engineering or within digital transformation is the sharing of information and enabling it. And you just hit on it, and I really like, this is not going to happen unless we can bring all of our vendors tightly into the equation here. And vendors and partners happen at all different levels. They're the teammates on the stage, they're mom and pop shops, they're international companies that have discriminating capabilities. And every one of those have challenges that we can say, oh, that's not for us. We're DoD, we have security requirements. Those days are gone, right? And we together have to put the excuses away, security, data information, IP, you name it. I can go on for about an hour, I'm sure we all can. It's time for us to come together, and we're going to win this fight, but we're going to do it together.
Well, Mike, David, Ryan, thank you so much for your expertise, for your commitment to participating in this event. I think we all learned a great deal. In lieu of speaker gifts this year, AFA has made a donation to enable additional airmen and guardians to attend the poolside barbecue event this evening. And let me tell you, I can tell you that they appreciate that. Our next set of sessions starts at 1:50. Not a lot of time, but I want to just give a pitch because the next session in this ballroom is about data management, and that includes AI, cloud, and analytics, which is all some things that are, I'm sure, near and dear to our hearts. So with that, thank you so much, and a round of applause for our speakers.